Hi again, guys. Once again, I think this problem is a little bit out of phase, but anyway, let's work it out and see how can I explain this to you. It says that the soil exerts the trapezoidal load here. We have three columns. This is a slab foundation of getting all the three columns here. And basically, when this happens, the summation of forces and moments should be zero or should be the same if you go from the top or from the bottom. In other words, if you have this distributed force, the equivalent force coming up, has to be equal to the summation of these three. And if I take moment with respect to any point, that should be zero. So that's what we have to start our problem, like that. First, you have a trapezoid. Remember, I told you the area of the trapezoid, but I don't know about you, but I never remember what is the location of the trapezoid. So I'm going to divide that trapezoid into two figures, one rectangle and one triangle, which is easier, for me at least. And I know this total distance from here to here is W1, and I know the distance from here to here is W2. So this little distance will be W1 minus W2, and this will be W2. Now I'm going to put my forces acting here. I know I'm going to have a force that is going to be equal to W2 times this total distance here, which is 1, 2, plus 6, 8. And the location will be half. So I'm going to have a force coming from the rectangular portion of the soil pressure right there at a distance of 4 meters, which is half of this. Let me check that again. 2.5 plus 3.5 is 6, 7, 8. Yes, 4 meters from there or from here. It's the same. And the value of that force will be W2 times 8. So 8 W2. And for the triangular part, I know that it's going to produce, if this distance is 8, I know that the resultant force is going to be located at 8/3 from this angle. 8/3, let me see really quick, is like 2.66. So that means that somewhere over the rainbow, somewhere around here, at a distance of 8/3, because remember I told you for the triangle is 1/3 of the base, and the base is 8. So 8 measured from the right angle, and the value for the force will be the height times the base. The base is 8. 8 times W1 minus W2 divided by 2, or 4 times W1 minus W2. That will be this force. That will be that force. Now we have everything that we need. Now you can start by doing summation of forces equals 0, and then you say, okay, I'm going to do this force, 4W1 minus W2 plus 8W2 minus 60 minus 80 minus 50 equals 0. And then I can take moment at any point. I can take moment here, and I'm going to get another equation in terms of W1 and W2. And I'm going to get a system of two equations with two unknowns, and I'm going to work forever and ever and ever. However, you have to work smart, not only work hard. If you realize I can just do moment at any point that I want to. So what if I say this point here, I'm going to call it A, and I'm going to start with that. Summation of moments at A has to be 0 because the problem is telling me that this is an equilibrium. Look what happened. When I take moment at the point where this load is applied, suddenly I am eliminating one of the variables because it's passing through the point, and then I can calculate directly the other one. So if I do that, let's start with A. It will be, and let's say that this is positive, that will be 60 multiplied by this distance. How much is this distance? This distance will be 8/3 minus 1. 8/3 minus 1. And then positive, because goes in this way. The other one will be negative this force, negative 80, multiplied by the distance from this point as well. What is that distance? That distance will be this distance, right? And this distance will be 3.5 minus 8/3. And here, this force, as I said, it doesn't produce anything. Let's work with this force now. This force is, the value for this force is 8W2, 8W2. And if it's located in this side, it's going to be positive moment, 8W2, multiplied by the distance from here to here. How much is that distance? That distance from here to here will be this. I know this is 4, and I know this is 4, and I know this is 8/3. So this distance will be 4 minus 8/3. 4 minus 8/3. And it will be positive as well. And last but not least, this one here is going to be negative 50 multiplied by the distance from here to here. And how much is the distance from this point to this point? That will be some distance. Let's see. How much is the total distance? The total distance is 8. 8 minus 1 is 7. And 7 minus 4, that will be the distance that I need. 7 minus 4. 7 minus 4. 7 minus 4. No, wait, 7 minus 4. What I'm saying, 7 minus 4. I'm placed here, right? At this point, this is 8/3. So this is 8. 8 minus 1 is 7. 7. And this is 8/3. 7 minus 8/3 equals 0. And look, this is our only missing variable here in this equation. So we can solve this problem. And we can say, I don't know, I'm going to try to group everything first. This is I'm gonna keep this for the last. So I'm gonna say 60 times 8/3 minus 1 minus 80 that multiplies 3.5 minus 8/3 minus 50 that multiplies 7 minus 8/3. Now I get this value, which is negative, and I'm gonna get this, pass it to the other side as positive, and I'm gonna divide it by this whole term, divided by 8 and divided by 4 minus 8/3. Remember, it's gonna be negative here, but I say that I have to divide it in the other side. So that value is gonna be 17.19 for W2. And of course, the value of W1 and W2 should be in kilonewton as well, per meters. Because if you realize this is kilonewton and this is meters. And in this case, this is meters. So it's going to be in kilonewton per meter. Because this is meter squared, yes. So that will be the value for W2. And if I need the value for W1, I just have to do summation of forces equals 0. So now I do summation of forces equals 0. And I have, let's start with the numerator, negative 60, negative 80, negative 50. And then going up, I have plus 4 W1 minus W2. And this one is plus 8 W2 equals 0. And then from here, we can solve for, let me see, for W1 is the one that we are looking, right? Yeah, W2, remember, is 17.19. So I'm going to put negative 60, negative 80. Oh my God, negative 80, negative 50, plus 8 times 17.19. That's going to be negative 52.48 plus 4W1 minus 4W2 equals 0, plus, now I have this value, minus 4W2 coming from here, minus 4 times 17.19. Then I get 121 divided by 4. I get W1 equals 30.31 kilonewton meter. And that will be it. You see how easy? Now, I want you to do the following so you can understand what I'm saying. Instead of doing the moment at A, I did moment at A because I know what was going on, but probably you find a problem like this in one exam and you are not going to see it straight away. I hope that you do, but probably you won't. So I want you to do this. Put the forces like I did, and then do summation of forces equals 0, and you say negative 60, negative 80, negative 50, plus 4W1 minus W2 plus 8W2 equals 0. Establish equation 1. With what unknowns? W1 and W2. Now do moment, wherever you want to do it. You can do moment here. And say 60, negative 60 times 1, negative 80 times 3.5, negative 50 times 7 in this direction, plus 4W1 minus W2 times this distance. What is this distance? 8 thirds. 8 thirds. Plus 8W2 multiplied by one distance, but this distance. How much is that? 4 equals 0. And then you get a second equation. And I'm describing it to you so you can copy what I said. And then you get an equation in terms of W1, an equation in terms of W2. And you solve for W1 and W2 in that system of equations. Try to do it in that way as well and compare the results. Should be the same. Thank you for learning, guys. Have a good day.